It's resolved. This video has been prepared for educational purposes only. No part of it may be reproduced or copied without the permission of the copyright holder.
Hi students, welcome to this session. This is Mathematics for IIT-JEE Main and Advanced by ML Khanna sir and videos by me, Subuh Nadeem. So, the next chapter which we have to do today is Trigonometrical Ratios and Identities. In the last lecture we did matrices of algebra. This is chapter number 12 of volume 1 of the book, Trigonometrical Ratios and Identities. So let us see first few of the concepts. Basically in this chapter we have more formulae and less concepts, and we have to apply this formula and we have to remember this formula and we have to practice many such questions so that we will know how to apply any particular formula in any particular question. So basically, first of all, we have sin A plus B formula. I am not going into its derivation. This is sin A cos B plus cos A sin B. This is the first basic formula. We generally prove it by geometry, coordinate geometry. Then from this formula, all other formula of trigonometry comes. Sin A minus B is sin A cos B minus cos A sin B. Next formula is cos of A plus B, which is equal to cos A cos B minus sin A sin B. After that we have a formula cos of A minus B, which is cos A cos B plus sin A sin B. So first these four basic formulas are very important for us. Then we have four other formulas, which is sum or difference to product. Sin C minus sin D is 2 sin C minus D by 2 into cos C plus D by 2. Then we have sin C plus sin D, which is written as 2 sin C plus D by 2 into cos C minus D by 2. Then we have cos C plus cos D, which is written as 2 cos C plus D by 2 into cos C minus D by 2. Then we have cos C minus cos D, which is written as minus 2 times sin C plus D by 2 into sin C minus D by 2. Here some places you may see that minus sign is not present. So what they do, they observe minus sign here and take it as sin D minus C by 2. In any way we can remember it, there is no issue. Then we have multiple angle formulas like sin 2 theta. Sin 2 theta is 2 sin theta cos theta. We can also write it as 2 tan theta by 1 plus tan square theta. Then we have cos 2 theta. Cos 2 theta is cos square theta minus sin square theta. Or we can also write it as 2 cos square theta minus 1. Or we can also write it as 1 minus 2 sin square theta. And in terms of tan, we can write it as 1 minus tan square theta by 1 plus tan square theta. Then we have formula of tan 2 theta. Tan 2 theta is 2 tan theta by 1 minus tan square theta. Then we also have formula of sin 3a. Sin 3a is 3 sin a minus 4 sin cube a. Then we have cos 3a, which is cos 4 times cos cube a minus 3 cos a. So you can see the pattern and you can remember it. Tan 3a is given as 3 tan a minus tan cube a by 1 minus 3 tan square a. Another formula which we have to remember is tan of x plus y plus z that is tan x plus tan y plus tan z minus tan x into tan y into tan z upon 1 minus tan x tan y minus tan y tan z minus tan z tan x. So this is another formula which we have to remember. You will also see some conditional identities. Those conditional identities are under some condition. I am not giving you the formula of those conditional identities, but I am giving you an overview that what can be the condition, like a plus b plus c is equal to pi. This could be the condition, or a plus b plus c is equal to 2 pi. This may also be the condition. So these are normal, most popular conditions under which some conditional identity may be given. Now, in trigonometrical identities, some other concepts are there, like if there is a cos theta plus b sin theta is equal to c. So what we do, we divide by a square root of a square plus b square. This becomes a by root over a square plus b square cos theta plus b by root over a square plus b square sin theta is equal to c upon root over a square plus b square. Now here these two quantities, a by root over a square plus b square and b by root over a square plus b square, you can say that suppose cos of alpha is a by root over a square plus b square, then automatically by the identity of cos square alpha plus sin square alpha is equal to 1, you can say that sin alpha is b by root over a square plus b square. So if you take this as cos alpha, this as sin alpha, you can also take this as sin alpha, this as cos alpha, depending upon the question's requirement. So here it will be cos alpha cos theta plus sin alpha sin theta is equal to c by root over a square plus b square. Now on the left hand side, this is the formula of cos of alpha minus theta, which is actually c by root over a square plus b square. And then we can proceed further as the question's requirement is there. Then we have list of questions which we are going to discuss today. This is the first question which we are going to discuss. This is problem set 1, question 5, page 540. The number of sides in two regular polygons are as 5:4 and the difference between their angles is 6 degree. The number of sides in the polygons. So suppose one polygon is having 5n sides, another polygon is having 4n sides. So these are the sides of the two polygons, and difference between the angle is 6 degrees. So how can we get the angles of these polygons? So first of all, we should remember a formula that angle of a polygon when added up, if you take any polygon and you add up the angles of these polygons, so sum of angles of n-sided polygon is actually equal to n minus 2 into 180 degree. You can verify also, like if it is a triangle, the number of sides is 3. So it is 3 minus 2, 1 into 180, that is 180 degree. If it is a quadrilateral, number of sides are 4. So 4 minus 2, 2 into 180, that is 360 degree. If it is a pentagon, number of sides are 5. So this value will come out to be 540 degree. So this you can remember that sum of angles of n-sided polygon is n minus 2, 180 degree. Now if it is 5n sided polygon, then 5n sided polygon, sum of the angles is 5n minus 2 into 180 degree, and individual angle you will divide by the number of sides. So one angle, what is the measure of one angle? That is 5n minus 2 into 180 degree upon number of sides 5n. Similarly, if there is a 4n sided polygon, then in that case the total angle will be 4n minus 2 into 180 degree. And if you want to take one angle of that polygon, that one angle is equal to 4n minus 2 into 180 degree upon 4n. Now this difference is given as 6 degree. So this is the first angle, this is the second angle, and we subtract them. So 5n minus 2 upon 5n into 180 degree minus 4n minus 2 upon 4n into 180 degree is given as 6 degree. This is given in the question. So we write it like this. Now we have to do the calculation part. So 5n and 4n LCM is 20n. 20n will go there, it will become 120 degree into n. And after taking LCM, this will become 5n minus 2 into 4, and this will become 4n minus 2 into 5 into 180 degree, of course. Now if we calculate, 20n minus 20n will cancel, and 10 minus 8 will be 2. So this will become 2 into 180 degree is equal to 120 degree n. So n is coming out to be 360 by 120, that is 3. So can you finally tell that what are the sides of the polygon? So sides of the polygon finally are 5n and 4n, where n is 3. So answer you will say is 5 into 3 15 and 4 into 3 12. So 15 and 12 sided polygons. Let me write it clearly. 15 and 12 sided polygons are there, in whose condition the question's requirement is being satisfied. Second question says, if theta and phi are acute angles, then sin theta is half, cos phi is 1 by 3. What can you tell about theta plus phi? So if sin theta is equal to half, theta you can directly get as pi by 6, that is 30 degree. What about cos phi is equal to 1 by 3? So you don't have to find the exact value of theta plus phi, rather you have to find the interval in which it lies. So pi by 3 to pi by 2, that is 60 degree to 90 degree, or 90 degree to 120 degree, or 120 degree to 150 degree, or 150 degree to 180 degree. So what we will say, cos phi is equal to 1 by 3. Let us see where does it lie approximately. So if we see, it is actually 1 by 2. If we measure, 1 by 3 is less than 1 by 2, right? And 1 by 2 is cos of pi by 3, cos of 60 degree. Cos 60 degree is half. So here we will say that cos phi is actually less than cos pi by 3. Cos phi is less than cos pi by 3, right? So in that case, since cos is a decreasing function, now since cos is a decreasing function in this interval from 0 to pi, so since these are acute angle 0 to pi by 2, so we will say that here the cos is a decreasing function. Since cos is a decreasing function in this given interval in 0 comma pi by 2, we can say that phi is greater than pi by 3. What else we can tell about cos phi? Is there upper limit also? So cos phi is equal to 1 by 3 is also less than greater than 0, right, which is cos of pi by 2, right? So cos phi is equal to 1 by 3 is greater than 0, which is cos of pi by 2. So again for the same concept we will say that phi is less than pi by 2. So what we are saying is that phi is greater than pi by 3 and phi is less than pi by 2. These two conditions on phi is there. So when we write these two conditions, we write it here that phi is between pi by 2 to pi by 3. Now theta is pi by 6. So if I add theta, so pi by 2 plus pi by 6 is here, and pi by 3 plus pi by 6 is here. So this will become pi by 2 here, 60 plus 90 degrees, 60 plus 30 degrees 90 degree, and 5 plus theta is here, and it will become 4 pi by 6, that is 2 pi by 3. So we can say that theta plus phi is between pi by 2 and 2 pi by 3. So theta plus phi is between pi by 2 and 2 pi by 3, that is 90 degree to 120 degree. This will be our answer. Next question says, if cos alpha by cos beta is equal to A, sin alpha by sin beta is equal to B, then prove that A square minus B square into sin square beta is equal to A square minus 1. So we can also write this question like this, that prove that sin square beta is equal to A square minus 1 by A square minus B square. This we have to prove. So we start from one side, which is A square minus 1 by A square minus B square, which is the right hand side here, and we say that let us find the value of this. So A square is cos square alpha by cos square beta minus 1 upon A square minus B square will be cos square alpha by cos square beta minus sin square alpha by sin square beta. So this will be equal to, let us take the LCM. So cos square alpha minus cos square beta into cos square beta will cancel and sin square beta will come into the numerator, into sin square beta upon, in the denominator, cos square alpha sin square beta, cos square alpha sin square beta minus sin square alpha cos square beta minus sin square alpha cos square beta. So this is equal to, in the next step, cos square alpha minus cos square beta can be written as cos alpha minus cos beta into cos alpha plus cos beta into sin square beta, like this, upon here cos alpha sin beta minus sin alpha cos beta is one term, and cos alpha sin beta plus sin alpha cos beta is another term, and this is equal to A square minus B square identity we have applied in the numerator as well as in the denominator. So cos alpha minus cos beta is 2 times of minus 2 times of sin alpha plus beta by 2 into sin alpha minus beta by 2. We did this formula little while ago, and cos alpha plus cos beta is 2 cos alpha plus beta by 2 into cos alpha minus beta by 2 into sin square beta is there, of course, upon this formula is sin beta cos alpha minus cos beta sin alpha, which is sin of beta minus alpha, and this formula is sin beta cos alpha plus cos beta sin alpha is sin alpha plus beta, right. This chapter is more about formula, as I told you earlier. You have to remember all those formula, and you have to also practice many more questions to know where such formula are getting applied. Please like, subscribe and share the channel, and also hit the bell notification to get the notification about the future videos. Now here 2 sin alpha plus beta by 2, as you can see, 2 sin alpha plus beta by 2 into cos alpha plus beta by 2 will become sin of alpha plus beta by multiple angle formula, and 2 sin alpha minus beta by 2 into cos alpha minus beta by 2 will become sin alpha minus beta into sin square beta is there, upon There is a minus sign, that minus sign can be absorbed here. This will become sine alpha minus beta, and this sine alpha plus beta. Now easily you can see that sine alpha plus beta is getting cancelled and sine alpha minus beta is getting cancelled. So what you are getting is sine square beta, which is actually the left hand side. So sine square beta was the left hand side. Hence you can say that right hand side is equal to left hand side. Hence we have proved this. Now let us see page number 549, question number 5 of problem set 3. For how many values of x between 0 and 2 pi is the equation valid? So again we can write it as 2 cosec 2x is 1 by sine 2x, and cot x is cos x by sin x, minus cot square x is cos square x by sin square x is equal to 1. Only thing we have to keep in mind that the domain of the equation should be intact. That means sin x should not be equal to 0 and sin 2x should not be equal to 0, which means x should not be equal to n pi and 2x is not equal to n pi, which means x is not equal to n pi by 2 here. So combining this and this, we can say that therefore x is not equal to n pi by 2. Now when you take LCM, this will become 2 sin x cos x and 2 will cancel. So before taking LCM I am writing it cos x, 2 is there, 2 sin x into cos x, so one more sin x, sin square x cos x minus cos square x by sin square x is equal to 1. 2 get cancelled. Now if we take the LCM, then LCM will be sin square x cos x, and the numerator it will become cos x minus cos cube x is equal to 1. So in the next step, let us take cos x common. So it will become 1 minus cos square x upon sin square x into 1 minus into cos x is equal to 1. Now 1 minus cos square x is actually sin square x. So cos x into sin square x upon sin square x into cos x is equal to 1. Now cos x cancels, sin square x cancels. This gives you 1 is equal to 1, which is an identity. So which is always true in its domain. We have already eliminated those portion of x which is not in the domain. So this is an identity. Now if it is an identity, then it is always true between 0 to 2 pi except at n pi by 2, that is pi by 2, pi, 3 pi by 2. So there will be infinite solution. So we will say that none, 0, 2, 1 is not enough. Actual answer is infinite solutions, infinite values between 0 to 2 pi except pi by 2, pi and 3 pi by 2. This next question is the value of sine cube 10 degree plus sine cube 50 degree minus sine cube 70 degree is equal to. So we did a formula of sine 3a, cos 3a and tan 3a. So here we don't need tan 3a, but sine 3a, cos 3a may be needed. Right now only sine 3a. So sine 3a formula was 3 sine a minus 4 sine cube a. From here you can write that sine cube a is equal to 1 by 4 3 sine a minus sine 3a. So when you use that formula here, this will become sine cube 10 degree, 1 by 4 will be common from all of them. Sine cube 10 degree will be 3 sine 10 degree minus sine 3 into 10. So that will be 30 degree. Then sine cube 50 degree, 1 by 4 will come outside, plus 3 sine 50 degree minus sine 150 degree. Then sine cube 70 degree, that will be minus 3 sine 70 degree, because there is a minus sign here, plus sine 210 degree. After getting this, we will write it as 1 by 4, 3 sine 10 plus 3 sine 50 minus 3 sine 70. Let us take in one bracket, 3 sine 10 plus 3 sine 50 minus 3 sine 70, and minus sine 30 will be half, minus half it will be, sine 150 is also minus half will be, and sine 210 degree is minus half. So plus is there, so this will be minus half. So in the next step, 1 by 4 into minus half minus half minus half, minus 3 by 2 into 1 by 4 minus 3 by 8. So minus 3 by 8 plus 3 by 4 into this term. So sine 10 plus sine 50, let us calculate that. So sine 10 plus sine 50 is 2 sine 60 by 2, that is 30, into cos 40 by 2, that is 20. And what about sine 70? Sine 70 is the complementary angle of 20 degree. So this will be minus cos 20 degree. So this will become minus 3 by 8 plus 3 by 4, 2 sine 30. Sine 30 is half. So 2 and half will cancel, and it will be cos 20 degree minus cos 20 degree. And cos 20 degree will also cancel here. So it will be 0. So minus 3 by 8 plus 3 by 4 into 0 will give you final answer as minus 3 by 8. So which option is this? Minus 3 by 8 is option number D. Okay, now let us come to the next question, page number 556, problem set 4, question 33a. It says if tan theta by 2 is root over 1 minus e by 1 plus e into tan phi by 2, here it is tan theta by 2, here it is tan phi by 2, prove that cos phi is this. So if you want to do this, what you have to do is, again let us start from the left hand side, or what we can do is, let us start from the right hand side, that is better. That is cos theta minus e by 1 minus e cos theta. Now cos theta is 1 minus tan square theta by 2 by 1 plus tan square theta by 2. So cos theta is 1 minus tan square theta by 2 upon 1 plus tan square theta by 2. So using that, and tan theta by 2 value we know from here. So using that and using this, next system can be written as cos theta is 1 minus tan square theta by 2, that is 1 minus e by 1 plus e into tan square phi by 2, and then minus e is here, upon 1 plus tan square theta by 2 is also there, sorry. So we have to write here upon 1 plus 1 minus e by 1 plus e tan square phi by 2. Don't be afraid of calculation, it will get simpler step by step. In the next we have 1 minus e cos theta. So 1 minus e cos theta is this, and tan theta by 2 is this from here. So this will become 1 minus tan square theta by 2, 1 minus e by 1 plus e tan square phi by 2 upon 1 minus 1 plus 1 minus e by 1 plus e tan square phi by 2. So this is how we have written the right hand side. This is right hand side, further this is right hand side. Now be quite cautious in calculation here. So in the next step, when we take LCM, it will come out to be in the numerator 1 plus e, 1 plus e will come, minus 1 minus e tan square phi by 2, right. So this is the LCM, 1 plus e minus 1 minus e tan square phi by 2, 1 plus e will get cancelled and this will get multiplied here. So minus e into 1 plus e into minus e into 1 minus e tan square phi by 2. This is in the numerator. What happens in the denominator? So what happens in the denominator is uh, 1 plus e, of course, here, and this will go here. So 1 plus e plus 1 minus e tan square phi by 2 minus e this is getting cancelled. So this is minus e into 1 plus e and plus e into 1 minus e tan square phi by 2. This is what we are getting here. Now in the next step, I need to erase some of the thing which I have written above to get enough space. So just see the calculation part. I have done 2-3 steps in one step mentally, but it is not necessary for you to do it mentally. You can use space to calculate. So this will be equal to, what else will getting cancelled here? 1 plus e minus e, so e and minus e will cancel, minus tan square phi by 2 and plus e tan square phi by 2 minus e tan square phi by 2 is getting cancelled. So this is coming out like this. This will become 1 minus e and here it will become minus 1 minus e plus e square. So plus e square plus e minus 1 tan square phi by 2 in the numerator upon, in the denominator, let us see what is getting cancelled, e and minus e, it is becoming 1 minus e and here tan square phi by 2 and minus e plus e, so this will get cancelled. So tan square phi by 2 minus e square plus e and minus e square from here also. So minus e square and here from also minus e square. So minus e square minus e plus e minus e plus, minus e tan square phi by 2 plus e tan, fine. Then it is minus e square tan square phi by 2 minus e square. So minus and plus tan square phi by 2. So is there one extra e I have taken here? Minus e into 1 plus e. 1 plus e was fine. 1 minus e tan square phi by 2 was also fine. Then minus e into 1 plus e plus e into 1 minus e tan square phi by 2, it is fine. In the numerator, 1 plus e minus 1 minus e tan square phi by 2 minus e into 1 plus e minus e into 1 minus e tan square. This is also fine. So e and minus e get cancelled, e and minus e get cancelled, and here minus e tan square phi by 2 plus e tan square phi by 2 is getting cancelled. Sorry. So I haven't cancelled this, that why is this confusion. So now we have with us 1 minus e square. So this is 1 minus e square, and here it is minus plus e square minus 1 tan square phi by 2. E square minus 1 tan square phi by 2. In the denominator, 1 minus e square, fine, and here 1 minus e square. So this is plus 1 minus e square tan square phi by 2, fine. After simplification, this is what we are getting. Now, in the last step, what we will do? We will divide by 1 minus e square in the numerator and in the denominator. So this will become 1 minus tan square phi by 2 in the numerator on dividing by 1 minus e square, and 1 plus tan square phi by 2. And this value is nothing but cos phi, which is actually what we have to prove. 1 minus tan square theta by 2 by 1 plus tan square theta by 2 is cos phi. This is what we have to prove. This is equal to the left hand side, hence proved. So initially the calculation was little difficult, and when you are doing it mentally, then there are chances of some error, as we got an error here. Later on we corrected it. So you can do this step by step in 2 more 3 steps, and there will be less chances of error. For all real theta, prove cos of sin theta is greater than sin of cos theta. How can we prove this? So let us assume that this is true, and we will come to some result which is universally true. So cos of sin theta minus sin of cos theta is coming out to be greater than 0. This is what they are saying is true. You have to prove it now. This is cos of sin theta minus sin cos theta can be written as cos of pi by 2 minus cos theta. Complementary angle formula. So this is cos c minus cos d, which can be written as cos of c plus d by 2, sorry, not cos c minus cos d, we write as minus 2 sin c plus d by 2 into sin c minus d by 2 is greater than 0. Now minus 2, so there is a minus sign here. We absorb it and take it on the right hand side. So this will become sin pi by 2, it will become pi by 4, sin pi by 4 plus sin theta minus cos theta by 2, and here it will become sin theta, or instead let us absorb this minus sign into this. So this will become pi by 4 minus sin theta plus cos theta by 2, and it is still greater than 0 because I have absorbed the minus sign into this. Now let us take any one of them first. Let us take this first one, pi 4 plus sin theta minus cos theta by 2. So this sin theta minus cos theta, if we talk about this sin theta minus cos theta mod is always if you multiply by root 2 and divide by root 2. So you can say that this is equal to root 2 into mod of cos theta plus pi by 4. This is the concept which we did in theory little while ago in the last slide. So we multiply by root 2 and divide by root 2. So this will become cos theta cos pi by 4 minus sin theta sin pi by 4, which is cos theta plus pi by 4 mod, which is always between 1 and minus 1. So its mod is less than equal to 1. So this is less than equal to root 2. So we can say that sin theta minus cos theta is always between root 2 and minus root 2. Now if we divide by 2 here, so this will become minus 1 by root 2 less than equal to sin theta minus cos theta by 2 is less than equal to 1 by root 2, right? Now sin theta minus cos theta is between this and this, then pi by 4 plus sin theta minus cos theta by 2 will be between pi by 4 plus 1 by root 2 and pi by 4 minus 1 by root 2. Now what are these values? What are they, positive, negative? What type of values are these? So here pi by 4 plus 1 by root 2 is definitely positive value, and pi by 4 minus 1 by root 2, if you want to calculate 3.14 by 4, that will be approximately 0.8, right? And 1 by root 2 is 0.7. So when you will subtract, you will see that this is also a positive value. Okay, you go into the 3-4 decimal places and you will see that the subtraction of this is also positive value, which means this thing is between two positive values, which means that this will always be positive. So sin and further you can say that this is between 0 to 0, it is greater than 0, right? So this thing is greater than 0. You can exactly say it is greater than 0, not equal to is needed here. And pi by 4 plus 1 by root 2 is less than pi by 2, right? So this is less than pi by 2, because pi by 4 is somehow greater than 1 by root 2. Again same reason. So what happens finally, that this particular value is between 0 to pi by 2. Sine of 0 to pi by 2 is always positive. So you will say that this term from here to here is a positive term, because the angle is in the first quadrant and sine of an angle which is in the first quadrant is positive. Similarly, as we proceeded for this, we can proceed for this also easily, and in the end we will do pi by 4 minus of this, and we will come to the same result, that this angle is in the first quadrant. So this value is also going to be positive value. So product of two positive values is always greater than 0. That means our assumption was true. So we did these steps, and after that this step is very important. Let us see the next question here. If tan alpha is 1 by root over x square plus x plus 1, tan beta is root x by root over x square plus x plus 1, and gamma is this, then prove that alpha plus beta is equal to gamma. So this we have to prove here. So what we do for ease of calculation, let us take tan alpha is equal to 1 by root over x into root over y, where y is equal to root over x square plus x plus 1. So instead of taking this big value, I am denoting it by y, not under root. Similarly, tan beta is equal to root over x upon root over y. Again, y is same thing. And when we talk about gamma, so gamma is equal to 1 by x cube plus 1 by x square plus 1 by x to the power 1 by 2. Now, when we take LCM, x to the power 3 by 2 is the LCM, and in the numerator 1 plus x square to the power 1 by 2, which is nothing but the square root of y upon x root x. So, this is tan gamma actually. They have missed writing tan. This is tan gamma. Now, let us take tan alpha plus beta. Alpha plus beta is equal to gamma we have to show. Therefore, tan alpha plus beta is equal to tan alpha plus tan beta by 1 minus tan alpha into tan beta. This is one more important formula which we have to remember. So, tan alpha plus tan beta is 1 by root x root y plus tan beta is root x by root y by 1 minus tan alpha is 1 by root x root y and tan beta is root x by root y. So, root x cancels and here it will become 1 plus x upon root x root y divided by y minus 1 upon y. So, this is coming, now this can be written as 1 plus x into y upon y minus 1 into root x root y. Now, if you see 1 plus what we have to show is alpha plus beta is equal to gamma. So, that should be tan gamma root y, okay, root x is there and x. So, root y is there, root x, one more x we need and we can need to cancel this, okay. So, what we can do here is 1 plus x into root y will become root y into root y upon and y minus 1, this y minus 1 from here, this will be x square plus x, which is actually x into 1 plus x. So, we can write x into 1 plus x into root x. So, this 1 plus x will also get cancelled and what we are getting is root y by x root x. Now, this root y by x root x is nothing but tan gamma. This is equal to tan gamma. So, tan alpha plus beta is coming out to be tan gamma. Therefore, finally, you can say that alpha plus beta is equal to gamma, proved. Okay. If tan x is equal to b by a, then root over a plus b by a minus b plus root over a minus b by a plus b is equal to which of these options? So, we can write this as square root of 1 plus b by a by 1 minus b by a, of course, and this one as square root of 1 minus b by a by 1 plus b by a. Now, in the next step, b by a is tan x. So, root over 1 plus tan x by 1 minus tan x plus root over 1 minus tan x by 1 plus tan x. Let us take LCM. So, this will be 1 plus tan x, this will be 1 minus tan x. 1 plus tan x because square and square root will cancel and 1 minus tan x upon 1 minus tan square x under root. Tan x get cancels. So, 2 upon square root of 1 minus tan square x. Now tan square x can be written as sin square x by cos square x. So after taking it from the under root, or let us write it like this first, 1 minus sin square x by cos square x. Cos x will come outside, it will be 2 mod of cos x upon root over cos square x minus sin square x is cos 2x. Is there any such option? 2 cos x by root over cos 2x. Yeah, option number B is there, which we can take. Okay. The next question is page 590, problem set 6, question number 27. In a triangle PQR, if 3 sin P plus 4 cos Q is equal to 6 and 4 sin Q plus 3 cos P is equal to 1, then the angle R is equal to. So here again, let us do one thing. Let us square this also, square this also and add. So squaring and adding. What will happen? 9 sin square P plus 9 cos square P. That will be 9, because sin square P plus cos square P is 1. 16 cos square Q plus 16 sin square Q. That will be simply 16. What else? Plus 2ab, that is 24. Sin P cos Q, from here cos P sin Q, they are also 24. So sin P plus Q is equal to 36 plus 1, 37. So this will become 25, 37 minus 25 is 12, 12 upon 24 is 1 by 2. So sin P plus Q is equal to 1 by 2. So from here, what we can say is P plus Q could be equal to pi by 6 or 5 pi by 6. Now the question comes that should we take pi by 6 or should we take 5 pi by 6? So if P plus Q is pi by 6, then R is 5 pi by 6. And if P plus Q is 5 pi by 6, then R is pi by 6. Now both the options are there. Which option should we take? So in that case, we have to see any one equation. Let us talk about this equation, 3 sin P plus 4 cos Q. Is equal to 6. So 3 sin P plus 4 cos Q, basically, since we are taking P plus Q is equal to pi by 6, if we are taking this situation, that P plus 6 is equal to P plus Q is equal to pi by 6, if we are taking this, then we know that sin P is going to be less than 1 by 2 and cos Q will be less than 1, because P plus Q is equal to pi by 6. So P value will be less than pi by 6. P is less than pi by 6, right? So if P is less than pi by 6, then in that case sin P is less than half and cos Q is anyways less than 1 because Q is greater than 0. So in that case, 3 into 1 by 2 plus 4 into 1 will give you 3 by 2 plus 4, which is 11 by 2, which is less than 6. So in no situation it will become equal to 6, but it is saying that this is equal to 6. So this is not true, which means we can't take P plus Q is equal to pi by 6 or R is equal to 5 pi by 6. Instead of that, this cancels, we have to take this, which means we have to take this and this is get cancelled. So R is equal to pi by 6. So these were some of the questions which we have discussed in this chapter. We will meet again in the next chapter, trigonometric equations. Thank you.